Alright, this is Thomas Sedlak. I've made my learning center about matter, the states of matter and how matter can change. The grade level is for second graders. The NGSS standards are, let's see, 2-PS-1-1, plan and conduct an investigation to describe and classify different kinds of materials by their observable properties. 2-PS1-2, analyze data from testing different materials to determine which materials have the properties that are best suited for an intended purpose. And 2-PS1-4, construct an argument with evidence that some changes caused by heating or cooling can be reversed and some cannot. For cross-curricular standards, we have some activities that involve both reading and writing. Most of these activities are going to involve writing in their journals, and one of these activities requires that they read the book Change It, Solids, Liquids, Gases, and You, appropriate for kindergartners to second grade. For materials, they're pretty simple. We have just a few basic materials. The specifics don't matter too much. We've got some paper, rubber band, cotton ball, stick, leaves, a metal cube, some ice cubes, and some water in plastic baggies. And presumably for a full class, I would have several of these, several of each. For the first activity, we have Matter Madness. Well, they will be essentially taking these items and they're going to figure out the properties of these items and compare them. And they're going to use, oh geez, the glue messed it up. They're going to use a chart like that to keep track of everything. Obviously, that can be adjusted. For a class, I would have several of those printed out. The second activity is for that second standard, it's evaluating the usefulness of each item. After they read that book, then they're going to be essentially looking at the materials they've been presented with and deciding which one would be useful for building with, and then extrapolating, there's different states of matter, which state of matter seems to be the most useful for building with, and are there uses for the other states. For the third activity, they're going to be looking at bags of ice cubes, and they're going to compare how quickly they melt when held in their hand versus just on the table. And they're simply just going to count how long it takes to melt. They're going to have to think about whether or not that melting can be reversed. And then they're going to be asked about, ice is solid, water is liquid. Can water turn into a gas? How can that happen? What do we call that? For the fourth activity, this would require a class presentation. This is going to require the teacher to have an egg and some method of boiling the egg. So the teacher's going to demonstrate that when you cook the egg, it doesn't melt. It actually, the inside goes from liquid to solid. They're going to ask if it can be undone. The students are going to guess while the teacher puts the egg in the freezer. And then the students are going to think about what would happen to their own items, the various materials here, what happens when they're heated, what happens when they're cooled, are some going to melt, are some going to freeze, can that be undone, yes or no? And then they're going to test that out by putting their items in the freezer for about half an hour, and then seeing the results and seeing if they were right or wrong. For assessment, it's going to be pretty simple. Most of these, it's going to be like this worksheet, pretty much would just be assessed for completion. Other activities, most of them involve writing, journals, a couple of sentences to some degree, and for each of those, that would be graded both for participation and for understanding. So if they don't necessarily have to be right, they just have to put effort in to understanding. Hopefully by the end they'll be correct, and in the exit ticket, correctness will play in more. The exit ticket itself is coming up with 3 different items for each state of matter. Just a simple listing that were not in the lesson very specifically. So things that, no water, no ice, no metal, having to think outside the box a little bit. And just to see the rest of this, since I didn't show it super well, they are given examples of different solids, liquids, and gases, and little factoids about then. And that's pretty much all I got. Hopefully this turned out well. I had to film it in my garage.